Welcome everyone, parallel and perpendicular lines. On this video we will talk about how we decided by checking slopes of line if they are parallel and perpendicular. So we are not going to draw some lines. I'm not going to ask the given lines are parallel or not only by looking the shape. I'm going to ask you, or we are going to decide it only looking the equation or linear equation, and we will decide it are they parallel or perpendicular. First thing, we are going to talk parallel lines. So two different lines are parallel if and only if they have same slope. So if their slopes are same, we will say they are parallel lines. Okay, let's write some equation here. Y equal, let's say 1 over 2 x, let's write that one on the parentheses. 1 over 2x plus 1. So, okay, that's the 1 over 2x plus 1. Let's write another one. So I'm going to keep 1 over 2x same. So I'm going to copy this one on control. Yes, I will copy that one. It's 1 over 2x minus 3. So that's the slope. If it's using y equal, so slope intercept form I'm going to use. So 1 over 2, 1 over 2. Our slope is 1 over 2 here. Let's check. Yes. As you see, that's parallel to the second line. 1 over 2x minus 3, 1 over 3x plus 1. These are two slopes. Or let's check another one. I'm going to use this time minus 2x plus 4. And let's make it clear on the screen. I'm going to use brown color, and the other is so that's the slope intercept form again. I'm going to use same slope, minus 2x minus 1. Okay. Oops. Sorry about that one. Let's change the color of it, brown, okay, and the second one, let's change the color of it to the green. Okay, that's good. As you see, brown and green, they have slope, as you see, negative 2x plus 4, and this is negative 2x minus 1. They are parallel, it's very clear on the shape, and this 1 over 2, slope is 1 over 2, and slope is 1 over 2, they are parallel. When the lines have same slope, so they are parallel lines. Okay, let's continue identifying which lines are parallel. So here, that's a slope-intercept form. So from slope-intercept form, you can directly say the slope is minus 1 over 2. For that one, slope is negative 1 over 2. Okay, if you check that one, this is the point slope form, and slope is again minus 1 over 2. So slope is negative 1 over 2, and these two are parallel. So these two lines, they are parallel lines. Let's check that one. I'm not sure about their slope because they are not on point slope form or not. They are not in a slope intercept form. So I need to change it. So I'm going to write them slope intercept form. Let's say plus 2x plus 2x, 3y equal 2x plus 4. So that's a positive 2x. I don't need to write coefficient, and that's a plus 4. Divide by 2, and you need to divide all of them by 3. Sorry, not 2. Divide by 3, all of them divide by 3. So 3 divided by 3, 1y. So that's 1y. As a fraction, you can separate that one. 2 over 3x plus 4 over 3. So what is the slope? Slope equal 2 over 3. I'm going to check that one. If that has the same slope with the previous one, so they are parallel. So I'm going to write that slope intercept form. As you see, I have 6 times y equal 4x. Think about there's a plus 0. So if I only divide by 6 both sides, so y equal 4 over 6x plus 0. So I don't need to write that one. I think that's enough for. So y equal 4 over 6 is equal 2 over 3x. So what is slope? 2 over 3. So both of them has same slope, so the lines are parallel, so that line parallel to that one, and these are parallel each other. These are not, because they don't have same slope. Okay, let's continue. Show that ABCD is a parallelogram. What we know about the parallelogram? Opposite sides are parallel. So if I show that one and that one parallel, and these two, show that ABCD is a parallelogram. To show that, you need to show opposite sides are parallel. When opposite sides are parallel, so that means the shape is a parallelogram. How can I say that one? So I need to calculate the slope of the lines. Which lines? For example, that line. What is the name of that line? AD. So I need to calculate slope of AD. And I need to calculate slope of BC. If these two lines has the same slope, so I can say they are parallel. Let's check that one first. So what is the slope? Slope is equal y1 minus y2, so 5 minus 1 over x1 minus x2 minus 1 minus minus 1. So what is it? That's equal 4 over 0, so undefined slope. So that's the first. If I find the slope of BC and it's an undefined slope too, I can say these two are parallel. So what is the slope for BC? Now I'm going to look at slope of BC. Y2 minus y1, so 7 minus 3 over 4 minus 4. As you see, 4 minus 4 again 0, m equal 4 over 0, so undefined slope. When you call undefined slope, so they are parallel, they have same slope, these two are parallel. That's the first thing we have to find. Now AD is parallel to BC, we show that one. Okay, let's put it here. Let's continue. Now I need to decide it. Let's clean that part. I need to check that one. Is AB parallel to DC? How can I know? I'm going to calculate the slope of this line that passed through these 2 points and the DC that passed through the D and C. So same method, I'm going to use same method. If they have same slope, that means they are parallel. Let's check. What was the rule? AB, y2 minus y1, so 7 minus 5 over x2 minus x1. 4 minus, be careful here, minus 1. That's equal 7 minus 5 is 2. 4 minus minus 1, so 4 plus 1 is 5. 2 over 5. Let's calculate the DC here. Again, y2 minus y1, that's equal 3 minus 1 over x2 minus x1. 4 minus minus 1. M equal 3 minus 1 is 2. 4 minus minus 1 is 5. 2 over 5. They have same slope, so we can say AB parallel to DC. As you see, AD parallel to BC, AB parallel to DC, so AD, that line parallel to that one, and AB parallel to DC, so that shape is a parallelogram. That's how we decided by checking the slope.